Hello students, welcome back. In this video, we're going to dive right into our vertical shoot 'em up, or shmup, known as Nova Strike. We're going to focus on two main things here for Nova Strike in this video. First, our world. So we'll define space. We're going to have a ship that flies through space. We're going to define what space looks like and what objects will be in there. We'll create stars and have the stars move through our background. And then secondly, we'll create that player. Our player is going to be a ship that we can control and fly all over the space world that we just created. So let's head to the computer screen and we'll dive right in. So I have a web browser open right here, and I'm going to use an online IDE so that I don't have to download any software. We're going to write all of our code right here in the browser. Of course, if you have your own IDE installed on your computer, feel free to use it, but this is just a super nice option for us if we don't want to install anything. And so we are going to go to vscode.dev. And so when I click enter here, it launches Visual Studio Code in the web browser. So I'm just going to close that welcome tab right there, and then I'm going to come over here to open a folder, and I'm going to go to my desktop, which is where I have my Nova Strike folder. So my Nova Strike folder is selected, and I will click select folder. We'll allow, and then you can trust the authors of the files in this folder because those authors are me, and you can trust me, I promise. Now, when I open this, I get 8 subfolders here, lessons 1 through 8, and these are the 8 lessons that we are going to work through together to build out Nova Strike. So if I open these folders, you can see that each one has 2 files. There is a starter file and a final file. The final file is the completed version of the code that we are going to do for that lesson. I want to give you that completed version because we are going to be moving through the starter file together. This is the unfinished version of the game, and we will code many lessons or many lines of code together here. If you find that maybe you have a mistake or something's not working on a certain line, you can always go back to the final version to reference what that line should look like, and then you can type it out in the starter file. You could also just copy it and paste it into the starter file if you prefer. So we have that there to lean on when we need it. So let's go back to the starter file because this is where we are going to work. This is where we're going to do our learning. We're going to get our hands on the keyboard and get down into it. So let's minimize our browser though first, because we're also going to click on that Nova Strike folder, go to lesson number 1, and open the starter file directly in the browser. And so this is going to give us the ability to make changes to our code right here, and then see those changes directly in the browser as we play our game. So this is Nova Strike. All right, so my ship, I can move horizontally. I can't move up and down at all. Oh, where'd my ship go? I guess I went off the screen. Okay, so, and this is supposed to be space. I don't know why space is like this bland, like grayish green color, and I don't know what this is, this little teeny tiny dot. This looks bad. This is a really, really, really bad game. In fact, I would say that this game is broken. And so what we need to do is we have to take this broken game and figure out a way to unbreak it, make it playable, make it fun and fixed. So that's what we're going to do here in our starter code. Now, before we really dive into writing some of the lines of code here for this lesson, we got to get an overview of what is in this file. Well, this is an HTML file. And so HTML, or hypertext markup language, is essentially the language of the internet. All of the content that you see on the internet comes in the form of HTML. And HTML is built around a concept called tags. So here is a title tag. We have an opening tag. We open the title tag right here. And then we have a closing title tag. And content sits inside the opening and closing tags. The majority of tags you open and close. There are some that you don't have to close, but we'll leave it at that. You open a tag, you close a tag. You open a tag, you close a tag. And so right now, this content says Nova Strike. And that corresponds to the title that we see in the tab right here on our browser. So if I change that to, let's just say, my first name, Mike, when I refresh my web page, you can see that content changes. So that's how we can control the content of our page. Now, that's really bad. I don't want it to say Mike, so I'm going to undo that, Control Z to undo. But let's just look at some of the other types of tags we have. We got style tags, a body tag. This one is exceptionally important. It's called the script tag. And this is where JavaScript is going to live. This is the programming language of the internet, and it's the programming language that we are going to use to write our game. And so I have an opening JavaScript tag right here. And then I have a closing JavaScript tag right here. Now, if you notice, there is no content in between these tags. There's no code here. So what is the purpose of this particular JavaScript tag? Well, if you look, we have a really big opening tag, script, and then we have src for source. We are linking to some external library of JavaScript code. So this is bringing in a whole bunch of code into our program that we can use, that we can leverage to make our programming that much easier. And this library is called the P5 library. Now, the P5 library is a great JavaScript library used to render graphics to the web browser. So what are we rendering? What does that mean to render? Well, it means to draw things. And so if you look here, we're drawing a lot of things to the browser. We're drawing our background, we're drawing our ship, we're drawing this little blue star maybe, we're drawing some text here, we're drawing a HUD or heads-up display where we can display information. All of that is aided by this P5 library. The P5 library is going to give us access to a ton of functions that will help us make those drawings. All right, so let's see what else we got. Oh, hey, look, we got another script tag right here. So here we're opening the script tag, and if I scroll down, where are we closing that script tag? Well, all the way down here is where we close that script tag. So if you notice, there was a ton of JavaScript in there. That is the code for our broken, terrible game. Here's that broken, terrible game. Remember it? My ship that just slides off the screen. Pretty broken. All right, so all of this code here represents our current state of the game. And this is where we are going to work. This is where we are going to write out our code to make our game better. So let's look at what's inside of this second script tag. That first script tag brought in a library of code for us, the P5 library. Our second script tag is where we are going to write our own JavaScript code. So we got a lesson title, Nova Strike, Lesson 1, The World and Player. And then we have this thing called a mission checklist. So every single lesson is going to have a mission checklist, which is made up of 8 missions. And these 8 missions are going to be small little sections of code that we need to fix or write to make our game much, much better. Remember the terrible state of our game right here? I don't even know where my ship went. Oh, there he is. He's back. We're going to take this terrible state of a game and make it better by solving these 8 missions. Now, if we look, let's go a little bit further. We have something called the student edit zone, where it says we are safe to modify. The student edit zone, think of it like a collection of dials or knobs that you can turn and adjust to change how your game looks, plays, or feels. Anything that you change in here will not break your game. So if you want to say, hey, I want to change the HUD height, change that number. If you want to change your player size, change that number. And you can see those changes in real time. It will not break your game. Now, if we look, we've got a lot of great stuff in the student edit zone that we can tweak and adjust, but there is an end to the student edit zone. So watch out. Once you go outside of the student edit zone, any changes that you make could potentially break your game. But don't worry, we're going to make those changes together. And if you find that you broke your game, maybe you made a change on this line and your game's no longer working, just come back to the final version of the code. Find what that line should look like and rewrite it or copy it and paste it back into your starter file. Awesome. So it looks like outside of the student edit zone, we have some gameplay variables. All right, so we have 2 variables right now, a player variable and stars variable, and we'll get into what those are. And then we have some functions. Functions are going to be super powerful for us. We are going to use functional programming to write our game. If you think about a function, it's just a way to run a repeated bunch of lines of code over and over again. So this setup function has 3 lines in it. Now, if I wanted to run those 3 lines, say 4 times, I might have to write 3 lines, then 3 lines, then 3 lines, then 3 lines. That is 12 lines of code. But instead, I put them inside of a function, and what I can do is just run or call the setup function. Anytime I run or call this particular function, these 3 lines of code will run. And so that's a super helpful tool for us to use here in functional programming. Now, we've got 2 really important functions right up here at the top, and we see this comment It's a comment because it's in green. That means for your eyes only. The computer's not going to read it. It says these are P5 game loop functions. So remember that library of JavaScript code we brought into our program, the P5 library? Well, it's going to call these two functions for us. So the setup function is going to get called automatically at the start of our game. So when I refresh my page, boom, that setup function got called. I refresh my page, boom, that setup function got called. And inside of here, we are creating our canvas with a width, looks like 700 pixels, and a height of 700 pixels. We're setting a text font. And then we're calling a function reset game to defaults. So like we're resetting our default values for all of our game. That runs once. The draw function, on the other hand, gets called every single frame of our game. So that P5 library is going to run this function every frame of our game. If we're running at 60 frames per second, this function gets called 60 times in 1 single second. And what are we doing in here? Well, it looks like we're calling other functions. We're calling update stars, update player, and draw scene. So those 3 functions get called 60 times a second. Hey, let's just go look at what else we've got. So here are some other functions, our own personal functions. So these functions we have to call. So if you look, we have reset game to defaults. We called it right here. It's not getting called automatically. All right, so it looks like I got reposition players and stuff. We got generate star data, spawn star, update stars, update player, get input direction, draw scene. And inside of draw scene, we're calling some other functions. Draw background, draw player, draw HUD. And there are those functions, draw background, draw player, and draw HUD. So before we really get into it, because we're almost done here, we've got an overview of this file. I want to just lay this foundational idea. It seems like there's 3 things going on in this code right now. First, we are defining some data. So we're defining data here in this student edit zone. We're setting values for variables. Then it looks like we are maybe updating our data. So you see we got like update stars, update player, and then we are drawing our data. So if we look down here, we got draw background, draw player, draw HUD. Those are the 3 levels of our game development process. We are going to define our data, update our data, and then finally, we got to draw our data to the screen. So let's take that idea, define data, update data, draw data, and let's go to mission number 1. Mission number 1 says we have to set the star system constants. All right, so we're going to introduce our first system to the game. We want a bunch of stars in our gameplay world that are going to probably move down the screen. So that system, anytime we bring in a system to our game, we want to add constants so that we can tune those constants. Like a dial, we can adjust, turn it up, turn it down to change how that system fits or plays within our game. And that's a perfect place or perfect thing to put in our student edit zone. So if I look right here, here is mission 1, the star system constants. Now, if you didn't know that it was going to be right there, how do you get to mission number 1? Well, if you hit Control F or Command F on your keyboard right now, Control F, it opens up your search bar. And in here, you can type out mission 1. Mission 1 is a tag that only appears twice in this code. Once here in our mission checklist, and you can see it says 1 of 2. And then if you press these little arrows, you can go to the previous match or the next match. So if you go down to the next match, it puts us right where we need to be for our code. All right, mission 1 tag right here, star system constants. Set the constants for the star system. Determine how many stars there are, how big they are, and how fast they move. Okay, so right now we have 1, 2, 3, 4, 5 little dials that we can use for the star system. Our first variable is called star count. Now, if you notice, this is all capital letters, and there's a reason why. We have to declare our variables here in JavaScript, and we are declaring this variable as a constant or const. When you declare something as a constant, it means over the life of that variable, its value will not change. So once we create the number of stars we're going to have in our world, we're never going to change it. So right now we're saying, hey, let's assign a value to this variable. That's what one equal sign does. It assigns a value. We're going to assign a value of 1 to the variable star count, and then we'll never change it because this is a constant. Well, I don't like the number 1. What happens if I change it to 2? Let's refresh our page. All right, refresh our page. Well, I still only see 1 star. Well, why is that? Let's change it to 3. All right. I still only see 1 star. Why is it? Well, I'm going to tell you right now. There are 3 stars being drawn in this game. The only problem is we're drawing them 1, 2, 3. We're drawing them right on top of each other. So we got to figure out how we're going to change that. Well, let's think ahead. How many stars do we want in our world? I want a good number of stars. I'm going to do 90. Oh, not 990. I'll do 90 stars in our world. And then we're going to have varying sizes for our stars. So I don't want them to all be the same size. So I'm going to have a small star, the smallest star, and then the largest star, and then we'll randomly select our size in between those. So my min size, star min size, I'll set it to 2. And then my star max size, I'll set it to 5. And then our stars are going to move. They're going to move down the screen. And we're going to have them move at different speeds. So the minimum speed I'll have them move at is, we'll say 1. And the maximum speed I'll have them move at is, let's say 3. Perfect. So our star system is set. Very, very good. All right, and so now I think we can move on to mission number 2. So mission 2, I'll put it right here in my search bar, but actually it just brings me right down below. You probably saw mission 2 right there. It says background color. We are going to change the background color and star color and observe how it affects the mood of the world. Once again, changing the background color, changing the star color, this shouldn't break our game. We should be able to change colors. So this finds us in our student edit zone where we're safe to modify any of these values. So we got to just look at, we got another constant variable, so BG color, which means, hey, once we define the background color, we are never going to change it. So right now, it's set to this really ugly, like grayish green. I don't know about you guys, but that doesn't scream space to me. It doesn't scream outer space. So we are assigning it a value of this weird looking thing right here. Well, the first thing that we're going to note is it is inside of quotations. You see how that's inside quotation marks? Anything inside of quotation marks is called a string. And strings are a really important data type here in JavaScript. And we have a really special type of string. The string that we're working with starts with a hashtag. And so that tells us that it is a hexadecimal string. And a hexadecimal string is one of many ways that we can define color. So before we get into this, we got to learn a little bit about what a hexadecimal number is. I know you all know numbers, right? Let's count to the first 10 numbers. Everybody count to the first 10 numbers. Yeah, I know what you did. You probably went 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But in computer science, in programming, we don't start counting at 1. We start counting at our first digit, which is 0. So if I want to count the first 10 digits, I do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the things that I can build my numbers out of in the decimal number system, the system that we normally use to count. And then I run out of digits, right? There's no new digit after 9. So what do? Well, I go back to the beginning. I already started at 0, so now I start with a 1. So I'm going to go 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, on and on and on. Now, hexadecimal is no different, except we don't have 10 digits to work with. We actually have 16 digits to work with. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But then we've run out of unique numbers, right? If I do 1, 0, well, that's already using those two. So what do? We use letters. So we use A as a unique digit, B, C, D, E, and F. Wow. So in hexadecimal, the digit D represents the number 13. The digit B represents the number 11. Well, there's my 16 digits. I've run out of digits. So what do I do next? Where do I go? Well, just like before, I go all the way back to the beginning. I've already used 0, so now I move to 1. So I do 1, 0. 1, 1. So in hexadecimal, 1, 1 is 17. And we can keep going on and on and on here. In decimal numbers, colors typically go from 0 to 255. And in hexadecimal, that would be 0, 0 all the way to FF. So FF represents 255. And when we look at our hexadecimal string, this is actually 3 colors all in one. We have a red channel of our color, which is these first two hexadecimal digits. So for F, we have a green channel, and that would be 6, 1. And then we have a blue channel, and our blue channel here is 5C. And we can mix red, green, and blue channels to make any color that we want. All right, so let's use this understanding to change the background color of space. So right now we have, I don't know, let's up the red. Let's make it all the red. So to turn the red all the way up, I'm going to do FF. Now I want to turn the green all the way down, 0, 0, and I'm going to turn the blue all the way down, 0, 0. So now the background of space should be red. Let's take a look. Whoa, that is an ugly, ugly color for the background of space, but it proves our understanding of hexadecimal strings. Hey, let's change it. Let's add some green. Let's turn the green all the way up. So now I have all the red and all the green. Well, red and green together make yellow light. But that is an extremely bright yellow light. So I want to dull it. So the way I can dull this is lower the amount of red and green. I'm going to set the red channel to 9A and the green channel to 9A. And so now what we should see is a softer yellow. There it is. All right, well, that's kind of cool. What if we turned all channels on? So all the red, all the green, and all the blue. FF, FF, FF. What's this going to give us? It gives us white. So the presence of all colors in equal proportions is going to give us white. What about zeroing everything? So no red, no green, no blue. What's that going to make? Let's think about it. It makes black. Ooh, black is sort of where I'm sort of going. I kind of want that color, but I want a little bit of color in space. So let's take each channel and bump it up a bit. In the red channel, I'm going to do 2, 4. In the green channel, I'm going to do 2, 1. And in the blue channel, I'll do 2, 3. So roughly equal proportions in each channel. And that gives me like this kind of like soft grayish color. It's got a little tint of red to it. And I really like that. So that is going to be the color I'm going to choose for the background of space. Now, what about our star color? Right there is our little teeny star. We got one of them. I want to change its color. But if you notice, our star color is different. We're not defining our star color as a hexadecimal string. We're defining it as a RGBA string. So RGBA stands for red, green, blue, and alpha. And alpha is super important here. Now, red, green, and blue. You saw we can mix red, green, and blue to make any color. But here in this version, we use decimal numbers between 0 and 255. So this says give me no red, all of the green, and all of the blue. And when you mix green and blue together, you get cyan, that nice cyan color. So what's this last number? This last number represents the alpha channel, or the transparency of the color. And in this form, it's going to be somewhere between 0 and 1. Right now it's set to 0.75. So let's see what happens if we change this. If I set it to, let's just say 0.1. Oops, 0.1. That is going to make it extremely transparent. We are going to be able to see behind it a lot. Well, it should be transparent. Why is it not being transparent? Let me check here really quick. Ah, yes, this is actually a pretty clever mistake that we just witnessed. It's transparent. The only problem is we're drawing 90 stars on top of each other right now. Let's change our star count variable back here in mission 1 to 1, and we'll affect the transparency now. So when we change that to 1, you can see it is extremely transparent. Okay, you can see through it. If we set the transparency to 0, right, 0.0 we'll just do, then it's fully transparent. You don't see it at all anymore. If we set the transparency to 1, it will not be transparent. It'll be fully visible. So there it is. If we set the transparency to say 0.5, it will be semi-transparent. You'll start to see behind it. So I'm going to set the transparency back to 0.75, and I'm going to change the color of the star to have a red value of 120, a green value of 255, and a blue value of 180. And let's look at what that gives us. So I got mainly green. I got lots of green, and that is what one of my stars are going to look like. It sort of matches the player color right here for their core, so I like that. All right, and with that transparency proven, let's go back and let's change our star count back to 90 stars. Now we'll draw every single star right here in that same spot, and boom, it looks like they're not transparent anymore because we're stacking them on top of each other. So mission 2 is done. Of course, this brings up a problem. We're stacking every single star right on top of each other. So we are going to head to mission 3 now to fix that issue. Mission 3 finds us in a function called generate star data. We got to create the data for the star object. We're going to set the X and Y positions, the size, and the speed of the star. If you look here, we are returning or giving back out of this function something that exists inside of these curly brackets. When you have something in curly brackets, it is known as an object. And objects have properties. In fact, our star object here has 4 properties: an X property, a Y property, a size property, and a speed property. We just need to set them. So if you look right now, we are setting every star that we generate has an X property of 400 and a Y property of 200. X property of 400. 0 in the X direction is the left side, so that means move in to the right 400 pixels, and 0 in the Y direction is at the top, move down 200 pixels. If I change this, let's make it 100 and 500. Let's see if our star changes position. And there it is. Now it's 100 pixels in, 500 pixels down. But I don't want to draw every star in the same location. I want to randomize it. And so what we're going to do is, instead of hard coding that X property as 100, let's call a function, the random function. And we're going to say, hey, pick a random value between 0, which is the left side of our window right over here. And then we want to go all the way to the right side. Well, this right side represents the width of our canvas that we created. And there's a special variable for that. It's width. And let's do something similar in the Y direction. We'll say random, and we could go from 0, the top of our game, all the way down to the bottom, and that represents the height of our canvas. So 0 to height. And while we're here, let's just finish this out, because we don't want every star to have the same size or speed. The size, we randomly want to select from, well, how do I know what values I want? Oh, we had constants in mission 1 that we set. Remember, it was star size or star min size. Now look, if I start typing, I get this nice list of all of my options, and I can use my arrow keys to go up and down. I'm going to select star min size right here, and if you hit tab will autocomplete for you. Autocomplete is a beautiful, wonderful thing. We should use it often. And so that's the minimum value that we'll pick from, and then we'll go to star max size tab for autocomplete. We should probably do something for speed too. So we'll randomly select our speed from star speed min, tab for autocomplete. And then we'll go all the way to star speed max, tab for autocomplete. So now every time we create a star, it's going to be different. So let's take a look. Let's refresh our page. And if we did this right, we should see 90 stars randomly placed throughout the star field. Whoa, look at that. That looks awesome. If I refresh my page, the star field changes. This is really, really good. There's only one problem for me. I don't like that the stars are up here in the HUD. This HUD is a region that's going to be just for text that we're showing for our game. So I want to make sure that when I generate my stars, I don't generate up here. I start down here. Do you remember we started generating vertical stars at 0? We're going to push that down by a certain distance. And that distance, you can stay here, but I'll jump and show you where it is. If I click over here on the right, I can jump to any section of my code. I have a variable in the student edit zone called HUD height. That's the height of our HUD. It's currently set to 60 pixels. So let's change our Y value. Instead of going from starting at 0, let's start at HUD height. I'm going to go down my list and hit tab for autocomplete. And now changing that, my stars will generate correctly. Perfect. So I got no stars up here in the HUD. Ooh, this looks great. This world is coming to life beautifully. The only thing that I'd love to see is get those stars moving. So let's go to mission number 4. Mission number 4 says, hey, we have to move the stars. Stars should move down the screen as the ship moves forward. When a star leaves the bottom, we're going to reset it above the HUD. Okay, so we want those stars to start moving down the screen. I think we got to backtrack a bit, though, to get a full understanding of what we're doing here in this function called update stars. See, there's 3 functions that are all working together for our star system: generate star data, spawn star, and update stars. you are going to see this structure repeated over and over and over again. Anytime we want to introduce an object into our system, we generate data for that object. We'll have a generate star data. We'll spawn that object, spawn star, and then we will update that object, update stars. So let's say we want to make an enemy, like an alien. We'll have generate enemy data, spawn enemy, update enemies. Let's say we want to make bullets, generate bullet data, spawn bullet, update bullets. Now, we got to go up a little bit and look at our gameplay variables, because it's really important that we talk about these right now. We have a player variable. Hey, look, it's inside curly brackets. That is an object, and objects have properties. Our player has some properties: an X property, a Y property, a size property, and a speed property. That's going to come in handy in a couple of future missions. But for right now, let's look at the stars variable. Our stars variable is not defined with curly brackets. It's defined with square brackets. That means it is an array. And you can think of an array like a container that you can put objects in. We just created 90 stars. So where do they live? They live inside of this array or container. So I have star 1, star 2, star 3, star 4, star 5, all the way out to star 90, right? Star 90. Now, each star in our array, or each element in our array, lives at a certain position in that array. And just like when we started counting our numbers in decimal, we're not going to start positioning these at 1. This first position is the 0 position, then the 1 position, the 2 position, the 3 position, the 4 position, which means the last element's position would be 89. Now, that's really helpful because those positions, and really the term is indices, those indices can be used to reach in and grab something out of the container whenever we want to. So if I want to grab something out of this container called stars, I just type the name stars, square brackets, and then I reach in and I tell it what position I want to grab at. So if I say position 89, that's going to go in and get me that star. If I say position 2, it's going to go in and give me this star right here. And that's awesome. And one of the nice things that we can do is I have 90 stars. Maybe I want to do something to every single star that requires 4 lines of code. I don't want to write 4 lines of code 90 times. That'd be terrible. So I write 4 lines of code once and I apply it to everything that is in the array. And the way we can do this is we can start here at the beginning of the array and loop forward and apply the lines of code to every single element. Or I can start at the end of the array and apply the code and loop backwards through every single element. All right, so that is a little overview of those data types that we have in our gameplay variables section, because we're going to use this stars variable right now. So do you remember we generated the stars data and it said return? We're giving that object back. Where are we giving it back to? Well, we're giving it back to wherever it was called from. So we are calling it right here in the spawn star function. So if you look, we're taking that array stars, that empty container, and we're calling dot push, which means we are going to put something into that container and we're going to put it right at the end. And so what we put in is the star object that was given to us from the generate star data function. So right now, boom, I put a star in. Then I call it again and I put another star in. And then I call it again and I put another star in. And then I call it again and I put another star in. So there are my stars all the way out to what? What did we say? Star 90. All right, so I'm going to take that array that we now have populated and we're going to look at it in this update stars function. Because inside of here, that array we now have, we start with a for loop. It says for const star of stars. There's a couple of different ways we can loop over this array, and we're going to do it here using a variable star. So stars is the name of our array, and star represents an individual element in the array. And so we're going to run all of this code that exists right here. All of that code is going to exist and be run first for our first star. So our variable star will represent S1. Once it's done running all the code, we switch, and the variable star represents S2. Then we run all the code, and star represents S3, and then star represents S4, and then all the way until star represents S90, and then we stop. So let's take a look at what we want to do here to move our stars. It says stars should move down the screen as the ship moves forward. All right, so look, we are first targeting a stars property. targeting the star's y property. And right now, we are adding 0 to it. I don't think I want to add 0. Let's add, I don't know, let's add 3. Can I add 3? Let's add 10. Let's see what happens if I add 10 to it. Whoa! All the stars moved and they all went off the page. And they all moved really fast. They all moved at like the same speed. Well, what if I add can I add 1? Let's see what happens if I add 1. All right, so that looks better. But if you notice, all the stars are moving at the exact same speed. We don't want that. We said we wanted to vary the speed. Well, if you remember, each star, if I just go up to my generate star data, each star has a speed property that we set. And so it was randomly selected between 1 and 3. Let's use the star's speed property. So in mission 4, we're going to add that individual star's speed property. And now we should see them all moving at different speeds. Oh, that looks really cool. It's like we have like depth to our image. But they never come back. They're gone. We don't have any more stars. So this is really, really bad. So what we want to do is we want to reposition our stars. So look here. We are asking a question using an if statement. An if statement asks a question inside of these brackets or inside of these parentheses. And if that question answers yes or true, then we run this block of code. So right now it says false. Well, false is always going to evaluate to false. The answer to the question is always going to be no. So we're never actually running this code, which changes our star's x position, our y position, our size, and speed. It essentially randomizes our star and puts it back up at the top of the screen for us. So we got to ask a real question. When do we want to reposition the star? Well, we want to reposition the star once the star, goes off the screen down here. So how do we verify that? Well, we're going to target that little star's y property. It's getting bigger and bigger and bigger and bigger. And once it's bigger than the height of our canvas, it's time to reposition it. So right in here, let's ask our first question using an if statement. We'll say, if our star's y property is greater than the height of our canvas. If that is true, now we're going to run all of this code. And we should reposition our stars. Let's take a look. And we now have our infinite star field. That looks so, so cool. I can't wait to actually get a player that can move through it, because right now my movement is broken. I can't move vertically. I can only move horizontally. So let's head to mission number 5 and see if that will fix it for us. Mission number 5 says, well, before we start moving, we got to reposition the player ship at start. Right now, my player is starting like up here and to the left. That's silly. I want my player to sort of like start down here in dead center in the world. So mission 5 will hit the down arrow. And if you lost your search bar here, to bring it back up, remember, Control F brings that back up. And you can search for your mission tags. Mission 5 finds us in a function, reset game to defaults. I believe we said we call that, oh yeah, remember those P5 game loop functions? Setup, which runs once at the start of our game when we refresh, and then draw, which runs every single frame of the game. We saw reset game to defaults right here in our setup. So when we start our game, we are going to reset our game values. And in here, what are we resetting? Well, it says we got to reposition our player. Reposition the player ship on start. Place the ship in the middle, horizontal, and bottom, vertical of the screen. So our player object, if you recall, had an X property and a Y property. And right now they are set to 500 and 300 when we restart the game. Well, we don't want that. We want our player to be right in the middle of our horizontal canvas. So this represents the width. And if I divide the width by 2, I should get pushed right into the middle. So let's do width divided by 2 here in the X direction. Refresh. Okay, that sort of looks right. But what we've just set is the left side of the player to the middle, okay? So the player's X is this left side. So what I now want to do is I want to subtract or push them back by half their width so that their center is in the center. So we're now going to subtract to move them over just a little bit. We're going to subtract half of their width. So we're going to subtract now player dot the player has a X property, a Y property, a speed property. Oh, they have a size property. So we're going to subtract their size divided by 2. And that's going to center them horizontally perfect. Let's take a look. Yeah, and that shifted them just a little bit. That little bit matters here. Now we want to move them down. So I'm going to move them down all the way to the bottom of the canvas. So that's going to be our height variable. Let's see what happens. Refresh the page. Okay, so now they're all the way down here. Well, that's not quite right what I want. So I want to like bring them back up a bit. I want to have like some offsets from the bottom. And so if we look, I believe in our student edit zone, we have a player starting offset, constant variable of 100. So I'm going to set that. I'm going to subtract that. So I'm going to subtract it to move them back up. Player starting offset, tab for autocomplete. And now they are positioned exactly where I want them. All right, that looks perfect. So now I can move left and right, but we can't move up or down yet. So that's kind of a bummer. Let's move to mission number 6. But you know what? Before we do, let's see what else are we doing here in reset game to defaults. So we reset our player, and then look here. We empty out our star array. We make it empty, and then we use a for loop to create or spawn all of our stars. So this for loop starts at 0 and goes up to star count. Star count was 90. And each time we increase this variable I by 1. So we run this 90 times. We create 90 stars. So that's pretty cool right there. All right, mission number 6. Mission number 6 asks us to connect our input. So it finds us in this function, get input direction. And get input direction, we start by defining two variables, dx and dy. If you notice here, we're defining these variables using the word let. That means we are going to change their values. These are not constants. Notice they're not capitalized. They're not constants at all. So we can change them. Right now, dx is set to 0 and dy is set to 0. dx it means a change in our x position. dy means a change in our y position. And if you look, we are asking a question. We say if, and then here is our question. This question has two parts, and it uses these two vertical bars, which mean or. So the first question is, key is down 65. So what that means, key is down is a function that we can use to check if a key is currently being held down. What key? Key 65. Oh, I have no, what key is key 65? Well, every letter on the keyboard has a numerical key code, and the letter A is 65. So we're asking, is the A key being held down? Or is the left arrow key being held down? If either of those are true, this question evaluates the yes. And this little line of code executes. And we take that dx variable and we change it from 0, we change it to -1. We ask another question. We say, if key is down 68, that is the D key. So if the D key is pressed or the right arrow key is pressed, we take that dx variable and we make it +1. We add 1 to it. So if we think about it, what that's doing is right now dx is 0. I press the left key. dx is -1 and I move to the left. Negative is to the left. Right now dx is 0. If I press the right key, dx becomes +1, and +1 means move to the right. So that's why we have horizontal movement. We need to map something similar for vertical movement now. So let's do that. Let's ask a question. And if the answer to that question is yes, we're going to target not dx, but we'll target dy. And we're going to move them up the screen right now. So we're going to check to go up the screen. Up the screen is subtracting 1 here. That's a weird thing to think about. Going up is subtracting, but the top of our screen is 0. Remember that. So we have to decrease until we get to 0. What question do we want to ask? That's the thing we got to figure out. Well, we're going to ask to see if certain keys are being pressed down. So we'll say key is down. And then I'm going to check to see if the W key is down. The W code is 87. Or, so two vertical bars, key is down, and then we'll check the up arrow. See, up arrow, down arrow, left arrow, right arrow, those don't have key codes, so you can just call them up arrow. They're defined here. And then let's check a follow-up. We'll say if, now we got to do heading down the screen. So down the screen, we're going to make dy, we'll add 1 to it. We'll make it positive to increase its size. So the question we need to ask here is going to be key is down, and we're going to check for the S key. our S key is the code 83. Or key is down, and we'll check the down arrow. Hey, with that, let's see if our movement system is accurate. Now, I just like to space these out so it looks nicer. You don't actually have to space them. Let's refresh the page. I can move left, I can move right, I can move up, and I can move down. Hey, and if you look here, my down, I can't go off the screen, and let's check my up. I can't go beyond the HUD. So it's like I'm constrained in the vertical direction, which is good. I shouldn't go off the screen. But left and right, ooh, I can disappear for a little while. So we got to fix that. But before we fix that, let's look at one last important line right here in this get input direction function. We are returning the values of dx and dy. We changed them, right? So we return dx and dy as an object. Where is that going? Well, it's going wherever we called this function. So if I scroll up just a little bit, I find myself in update player. Update player gets called every single frame of our game because it's being called from that P5 library's draw function, right? Here it is. Draw, we said P5 calls it every frame of the game. We update our stars, update our player, and draw our scene. So update player gets called every frame, and we're returning this object, which has dx and dy, the directions we want to move right here. So now that variable move direction is that object. It is that object that has dx and dy in it. And so what we're going to use is that dx value. We're going to use that dy value to update our player's x property and y property. We grab move directions dx property. It's either 0, -1, or +1, and we multiply by our player's speed. This will move them to the left, to the right, or keep them stationary in the x direction. And then we do something similar in the y direction. We take that move directions dy property. It's either +1, -1, or 0, and multiply it by our player's speed to move them in the y direction. So that's a really nice system that we have there. But now mission 7 says, well, we got to keep them in the game window, right? We don't want them flying off the screen into space. So in order to do that, to constrain a value between a lower bound and an upper bound, we use the constrain function. And if you look right here, our y value is being constrained. And so we're going to mimic that function right here. We're going to target the player's x property, and we're going to say, okay, that x property, we want to constrain it so they can't go off the screen to the left or off the screen to the y. The constrain function takes 3 pieces of information. First, it's the value that you're looking to constrain. I want to constrain the player's x property, their horizontal position. And then it takes the smallest value it can take. Well, 0, that's our left side of the screen. And then the largest value it can take. Well, its largest value will be the width of our screen all the way to the right side. And let's test this out now. Are we constrained? So in the horizontal direction, I try to go to the left. Boom, I'm stopped. In the vertical or in the horizontal direction, going to the right. Okay, I think I left off the screen, but I didn't. Look, I can come right back. I'm immediately back. So what's happening is when we position the player's x position is this left side, and we're saying the left side is constrained to the width. So my ship is living right here. What I need to do is constrain it so that it's back just a ways. So I have to subtract that player size to keep it on the screen. So let's do width minus player dot size. We'll target their size property. Now we should be constrained correctly. And there I am. Oh, this is cool. I can fly all over the game world. I'm constrained. There's only one thing that's really, really bothering me right now, and that is that in the HUD, it says game name. That's not the name of my game. My game is not called game name. So let's go to mission number 8. Mission number 8 finds us inside of a function, draw HUD. So now we're going to talk about drawing things to our game window. If I scroll up, we've got draw scene. Draw scene calls draw background, draw player, and draw HUD. We're drawing all 3 of those things. And draw scene is getting called every single frame of our game, because if I go back, you can stay here. I'll jump. I'm going to jump to our P5 library's draw function. We update our players, we update our stars, and then we draw our scene. So that function is getting called every frame of the game. So we're drawing our HUD. What do we do here? Well, the first thing we're doing is we're calling no stroke. No stroke is a command that says, hey, I'm about to pick up a marker to draw something, but give me a marker that is invisible so you don't see the outline of the shape that I'm about to draw. And then we call fill. Fill is a way to say like, hey, we're going to put some paint in a paint bucket and we're going to paint our shape that we just drew. And right now, if you look, we're filling it with an RGB alpha string, 0 in the red, 0 in the green, 0 in the blue. That is a black color that is transparent with an alpha of 0.66. And then we draw a rectangle. A rectangle needs 4 pieces of information. The X and Y coordinate of the top left corner, in our case, 0, 0, that's right here. And then it needs the width of the rectangle and the height of the rectangle. So ours is our canvas width, and then we're going down our HUD height. So where that draws my nice transparent HUD right here. Excellent, excellent, excellent. And then we are going to fill in a different color. We grab our text color. So now we put a different paint in our paint bucket. We align our text in the horizontal direction to the left, our vertical direction to the center, and then we set our text size. So right now, like our text size is set to 18. Watch what happens if I bump it up to 60. Game name. Wow, it's a lot bigger. It looks terrible. But let's use this to discuss what it means to align text in the horizontal direction. Right now, we are left aligned, which means when we position our text, we're positioning it to the left end of our string. So right here, we're positioning like the G. So we're positioning the G at a X position of 15 pixels. So the text function takes 3 pieces of information. The string you want to display, its X position and its Y position. So right now, because we're left aligned, we're positioning the G at 15 pixels. If I change this to center aligned, what we'll do is we'll position the center of the string at 15 pixels. So like that space. So right now I should see the space appear right there where the G is. Boop, and that's perfect. So the alignment here is going to help us position text later on, but we'll keep it as left alignment. And let's get rid of this crazy, ridiculous size of 18 or of 60. Let's put it back to 18. And the last thing that I want to do is I just want to change this string. The name of my game is called Nova Strike. And so this will position my text at an X value of 15, starting at the left of the string because we're left aligned, and a Y value of 25, and that's going to be vertically centered because we're center aligned. Let's check it out. Our final finished game. Nova Strike is coming along wonderfully. I think this looks perfect. We got our moving star field. We got our player that can move all around space, confined to the game window. Things are shaping up really nicely here. We did a lot of great stuff in this video, and we're going to continue to build on this throughout the next 7 lessons in this game. So I can't wait to see you in our next video.